Okay, today what we're going to be looking at is phase shift. So far what we've done is we've been able to take a graph and we have made it taller. So in other words, we've increased its amplitude. We also have moved the graph and moved it either down or we've moved it up. Okay, so now what we're going to be looking at today is moving our graphs left and right. And so we call that phase shift. Now, when we're talking about phase shift, what's happening here is it affects what's going on the x-axis. So that's why, if you notice, we're looking at this C here. So it's very similar to the same process when we worked with parabolas. Okay, our basic parabola was y equals x squared. And then if we wanted to move the parabola left or right, we opened up the x and we threw in a number. The same thing is going to happen here, except the number we're going to be throwing in is going to be an angle. Because remember, along the x-axis, we're talking about angles when we're talking about trig functions. So at any time that you need to pause the video, please do so. So what happens is the phase shift moves the graph to the left or right. Just like parabolas, if C is negative, in other words, x minus C, the graph moves to the right. So it's the opposite of what we would expect. And remember in class what I told you, it's like it's so violent when they open up that x that it gets everything mixed up and it goes the opposite way of what we would expect it to do. And in fact, when we look at other functions down the road, the same is true there also. When we're affecting the x value, it always moves the opposite direction. So in other words, if C is positive, in other words, x plus C, the graph moves to the left. Now, the phase shift is in degrees, as I've already mentioned. Also, it affects the labeling on the x-axis. So far what we've done with the x-axis, it was those important values that I talked about. And I don't know if you remember what those important values, here they are again, 0, 90, 180, 270, 360. So we still need to have those in our mind, okay, but we're going to be moving all of those, moving the whole graph to the left or right. Now, just to give you an idea, actually, we're going to the internet for a second, and this isn't the one I particularly like. However, the one that I usually use is offline tonight, so this is what's going to have to do. So, I don't know if you can see that. What I'm going to do is I'm going to change the amplitude to 4. Oh, not quite 4. I'll change it to 3, 2. Change it to 2 just so it's a little bit larger for you to see. So what we're doing here, I don't know if you can see very well at the back, but it has y equals a sine bracket bx plus c plus d. So what happens when we put a value in for that c? So if I put in a negative value, what would you expect if it was x minus 30? Well, if what I told you was true, this point here should move over 30 degrees. Now let's see if that is true. Oh, if you notice that point, it was here, it moved over. So let's see what would happen if I moved it over. I'll take it back to 0 again. Same thing is true if I went 60. So here's the point we're watching. So 60, there's 90, so it should be somewhere around here where my cursor is. So let's find out if that's true. Yep, so it looks like that's what's happening. Now the same is true if I put a positive number in. So let's put a positive 45. Now it's a little bit harder to see on this applet because it doesn't keep the original one. So here's our original again. So this is the point we're looking at. I'm going to hit 45 again. Positive 45, so it should end up over here halfway, about a quarter way between the last one. And there it is again. Now, you're thinking, well, if you can just move one graph to the left or right, what really stops you from having a sine or cos? Well, really not a whole lot. Right now, this is a sine graph, okay? But I could get it so that it doesn't look like a sine graph anymore, even though it's still, I could have an equation of a sine graph. And the way I could do that is with a phase shift. Now, we know that cosine, for instance, starts at the highest point. Now, if I look at the highest point here, or here, this one's the closest one. If I take that highest point and I moved it back, okay, so if I put a x plus a number, I should be able to get this graph that's a sine to look like a cos graph, but have a sine equation. And I don't know if you can tell, that is 90. So let's take a look. If I put a positive 90, what will happen? And there it is. So it looks like a cos graph, but I have a sine equation. Now the same is true if I have a cos equation. I can turn it into a sine graph just by doing a phase shift as well. Okay, so let's get back to our lesson. So what we're looking at here, it affects the x. So we have new important values, and remember that the important values were 0, 90, 180, 270, and 360. Now the distance between those points, all those points, is 90 degrees. Okay, 90, 90, 90, 90. Okay, now when I do a phase shift, although those values will change, the spacing between those points is still going to be 90. I'm just picking up all of those points and moving them over. But the distance between my new important values is going to remain at 90 degrees. Now, there are two methods for graphing. Okay? And it depends on the person. It depends on the teacher, which way that they teach it. I've taught it both ways, and I can still teach it both ways. However, I'll tell you what both ways are. The first way is to draw the original graph and then move every point to satisfy the phase shift. Okay, so I draw the normal graph and then move every single point over. Okay, and that works pretty good. And a lot of textbooks use that method as well. Even if you look in your textbook, it does that method. The problem is with that method, if you draw the original graph and then you do a phase shift, so now you've got another thing, and then you draw another graph because you've got an amplitude change, and then you draw another graph because it's got a vertical displacement. So by the time you're done doing one graph, the answer that you're looking at has got like 5 or 6 graphs on it, and you don't know what you're looking at anymore. Okay? That's why I've kind of shied away from method number 1. So what I do is I usually do method number 2, and all it means is I'm going to add or subtract that phase shift number, okay, that number that's in with the x. I'm going to add or subtract it to those original important values, okay, the 0, 90, 180, etc. Okay, because if I do that, then I only have to make one graph and I can see what it is, and there's no guesswork on my part. Okay, so let's look at some examples now.